In this video, we're going to learn about database management systems and database development, particularly the steps of database development. So first of all, what enables you to make good decisions? The first thing that may have come to mind is information. Information comes from a variety of sources, including the internet, such as Google searches or just websites in general. It comes from friends, it comes from family, it comes from coworkers. So information is basically data that's been interpreted in a way that we can understand it and use it to our advantage to make a good decision. Now, what is data? Data is text, numbers, raw facts, figures, etc. that are stored in a database that we can access by querying, that we can update, we can insert, or we can delete. Additionally, there's this thing called metadata, which is data that describes the data, also known as a data dictionary. And we'll talk a little bit more about what is meant by metadata. So let's look at this through an example. If I were to ask you to interpret the data in the following table, you would not be able to tell me. So what is missing from this table for us to interpret it? You may say there's headers. And headers are the fields, the field names, that describe what is the data that is stored in our database. From here we can understand that this is probably a transaction table. But what type of transactions? We need a little bit more information, so metadata would help us get that information to be able to make a better decision. So if I give you this metadata, saying the product codes of B stands for burger, F stands for fries, and S stands for soda, now we have a better understanding that maybe this is a McDonald's joint or some other franchise. So let's look at another example of metadata with a class roster. So each one of these headers that we see up here are metadata. For example, we have a name, which lists out the fields that we're looking at. We have a type, which can be alphabetic or numeric or both, or we can have decimal. We also have length, which indicates the number of characters that can be accepted, the minimum value, the maximum value, what the description is of this column, what it represents, and also where that's coming from. This brings us to our next thing, which is traditional file processing systems. Organizations, as they begin, they don't really have the best way of managing their databases. In fact, a lot of them add piece by piece as they grow. And so you end up getting something that looks like this with a traditional file processing system. You have an orders department with 3 different applications, program A, B, and C, that interact with the filing system, which then interacts with 3 separate databases: the inventory database, the backorder database, and the customer master file. Then we have accounting department that has an invoicing system that they interact with the customer master file and the inventory pricing file. Then we have a payroll department that interacts with the payroll system with the employee master file. Do you see any issues that could occur with the traditional file processing system? Well, for example, if the orders department updated the customer information here, maybe the accounting department wouldn't have the latest updates. So we have inconsistencies. Additionally, we could have redundancy. We could have multiple customers inserted in multiple databases. We could have multiple products, multiple inventory. So it's very inefficient, and we need a better way to manage the traditional file processing systems. So how do we overcome these problems? That is through the introduction of the database management system. There are many environments that use a database management system. One of the most popular is Oracle. SQL Server, Microsoft's product, is another popular option. For this class, we're going to look at MySQL as it is a free alternative, and it will be easier for you guys to implement with your clients that you'll be working with in your group projects. So first, we have the database and the metadata as we described previously. Then we have a bunch of data that's all stored inside of that one database. We have a database management system that circles around and interacts directly with this. Then people that want to interact with the database basically work with the database through direct interactions, such as system developers or data and database admins. Or we have those that indirectly work with the database through front-end applications, such as end users. For example, us as customers, we're interacting with Google's data when we're writing a query in their google.com website. So now we're going to move into the database development process. This is the overview of the process, and then we'll talk about each aspect specifically. So a project is a planned undertaking of related events to reach an objective that has a beginning and an end. So we're going to walk through each one of these phases in order to determine how to develop a database. So to begin, let's talk about the requirements phase. The requirements focuses on collection, definition, visualization. So basically this is going and talking to clients, interviewing them, seeing what they want, what are their needs, what are the requirements that they have for their database. Then we specify what is possible, what is going to be the main focus of what we're going to work on first, maybe present a visualization of what we can accomplish. So the way that we visualize this is through a entity relationship diagram. This is a somewhat small entity relationship diagram, bigger than what you'll work with in this class, but just to give you an idea of the complexity, we have a bunch of entities or objects that interact with one another, and we have their relationships, we have their attributes that are associated with it. And we'll talk about this much more in detail as we go throughout the rest of this course. The next step is modeling. So modeling takes that ERD and then converts it into a model that we can easily use to build our database, to implement it. So it's this taking the abstract idea of the entity relationship diagram and making it into a more concrete idea that we can implement directly into our database. After modeling, we begin implementation. So that's taking the model that we just built in the previous slide, and then we're going to actually write the code that is going to create the tables inside of our database and link the tables together using primary foreign key pairs, which we'll talk about later in this course. The next step is to develop front-end applications. We could develop this after the database is completely done, or we could develop in synchronization as we're going through the implementation phase. A front-end application is basically the application that users interact with that is connected to the database so that you can have that indirect interaction. As we go through this course, we're going to talk about PHP and how to connect to our database and build a web application that will allow us to make that connection. So for example, we have forms and reports that are created that give us a general understanding of what we're going to do with this data. Then we get to deployment. There are 4 different ways of deploying this. First is through direct conversion. Direct conversion basically says that once we've created the new system, we're going to cut off the old system and begin with the new system. This is very scary because maybe you have some issues you didn't plan on, and that even through your testing processes, you didn't recognize this. So another approach might be the pilot conversion, is that you have a subdivision of your organization or even a sub-piece of your application that is implemented with this pilot conversion. Then you can have people test out your kinks and let you know what needs to be improved. And then once those kinks are worked out, then you switch over to the new system altogether. Then there's the phase conversion, where each piece, bit by bit, is implemented and we start phasing out pieces of the old system. This may be more like the Windows 10 approach now, as they're going through this phase conversion and having the insider group that is working to help Microsoft identify flaws before they release it to full production. Then we have parallel conversion, where both systems are run together until you've actually determined that the new system does exactly what we want it to accomplish, and then you cut off the old system. Then we get to use, direct and indirect use. This is those users that are going to interact either with the front-end application or directly with the database to make the changes that we need. So for example, direct use would be writing SQL, which you will do in this class, such as select count star from order line where order ID equals 4, or it may be done through the application user interface, and that would be indirect use. And then finally we have administration and maintenance. This is probably the most costly phase, because once we implement something, we then have to maintain it for the duration of its life cycle, however long that is. That may be for the rest of the duration of our company, or it may be for a limited amount of time. And how do we administer this? How do we administer who has rights to certain aspects of the organization? We don't want people to have too many privileges, then we run into security issues. At any time, we can go back in the development process. This way we can work through kinks, recognize that there were shortcomings, and try to fix those before we actually get all the way down to the very last step and realize, hey, we totally messed up. And then when you're done with each one of these steps, you begin again. Basically, anything that you want to add or change to your database, you will go back through this whole loop, and that's the next version of the database. So who's involved? We have those on the database side, such as database analysts, who are involved in the requirement stage. We have designers who are involved in the database modeling stage. And we have developers that are involved in the implementation stage. So when I was a database developer, I was very much involved in the implementation stage. I was building those front-end applications so that people could interact directly with the database without having to write SQL scripts. Now, some organizations are in the early stages, so a person could have the job as an analyst, a designer, and a developer all in one job. Then we have front-end employees or front-end jobs, such as application analysts that look at the requirements that are needed, and then application developers, those that actually develop the front-end applications. Then we have DBAs, database administrators, that are involved in the administration and maintenance, who has rights to what resources and how do we ensure that people have the rule of least privilege, which we'll talk about later in this semester, which is basically only granting the number of privileges that people need and nothing more. And then you finally have the end users like you and me and various others with relation to a bunch of applications we interact with every day. So there are various ranges of applications from single user database. Many of you may have heard of Access or Base, which is OpenOffice's version of Access. Access is very much used, although it's not a very good database because it really cannot be shared, although there are ways to bypass this. It really cannot be shared with others as it is a single user database. You run it on one machine, you interact with it on that machine. There's a two-tier database, which is the traditional thick client, which means that the client has a lot of the applications and most of the data is just offloaded onto the database server. And so we interact with the database management system in order to receive the data from the tables and view the relationships or interact with the database itself. Then we have the multi-tier database, which is the thin client, which means that the applications are not run on the client, they're run on a web server or some other server. For example, when you interact with almost any web client, Dropbox, OneDrive, Google, you name it, you don't have that application installed on your computer, rather it's installed on a server, and that application then interacts with the database server to get the information that we want. For the purpose of this course, we'll be focusing more on multi-tier databases and the reason why we do this is because it's a more secure way of managing our databases. And that is it for this lecture. If you have any questions, feel free to reach out to me via email.